So if you recall, when we're solving for the angles, we use our arc sine, arc cos, and arc tan on our calculators to do this. So there's this issue of we have our angle, we input into our sine, cos, tan, and the output is going to be our ratio. Okay? So this is a ratio. If we want to go the other way, we have to use, we start with our ratio A over B. If we're going in the other direction, we use our arc sine, arc cos, and arc tan. Okay, and our output is our angle. Okay, so now it's important to understand we always put, if with sine, cos, tan, our input is always our angle, our answer or output is always our ratio, and the reverse is true here. Now the problem with solving for an angle with theta, solving for the angle theta in standard position is that theta can take on two positions. Okay, so I'll give you an example here in terms of this. If we take the angle, we take an angle of 30 degrees and we put it into here and we use our sine function, sine theta, our output is going to be 1/2. Okay, because we have our 30 degrees here, the height is going to be 1/2. Problem is we also have at 150 degrees we have the same sine value, the same y positioning. So it's going to give us 1/2. So when we do the reverse of this, we have an issue here. Okay, because if we start with our 1/2 ratio and we do the inverse, okay, the opposite, we have to come up with two possibilities. Okay, because it's 30 degrees and 150 degrees. Okay, in fact, we have to always consider two angles when we are using our arctan, arc cos, and arc sine. So in this case here, our sine theta is 1/2. So we have our opposite over hypotenuse, or our y over radius, 1/2 in this position here. And we also have 1/2 in this position here. There are two possibilities. So when I solve for this on my calculator, okay, this happens to be a special angle, so we don't really need our calculator, but if I solve for this, I end up with 30 degrees in my theta 1 position. My calculator will give me the 30 degrees. Now, if I want to find the green positioning there, I have to do 180 minus 30 degrees, so our theta 2 works out to be 150 degrees. And this is because of the symmetry of sine. Sine is symmetrical across the y-axis, so it's going to give us these two possibilities. So we need to worry about the two possible solutions in a circle because the circle is symmetrical. Okay, so because of the symmetry in the circle, we have to worry about being able to find things across the line of symmetry. So why don't we worry about theta 2 in the triangle? Because theta 2 is beyond 90 degrees. And you can't have 90 degrees. You can't have it. It makes the total angles greater than 180 degrees. So it makes the angles in the triangle greater than 100 degrees, which is not possible.